In this video, I will talk about the binomial distribution. With a binomial distribution, the experiment is repeated for a fixed number of trials, where each trial is independent of other trials. There are only two possible outcomes of interest for each trial. Either a success or a failure. The probability of success is the same for each trial. The random variable x counts the number of successful trials. So here's some notation for a binomial distribution. N is the number of times the trial is repeated. P is the probability of success, whereas Q is the probability of failure. To calculate the probability of failure, you take 1 minus P, and that will give you Q. X is the random variable that represents a count of the number of successes of each trial. So we're going to look at these examples and we're going to determine whether or not it's a binomial experiment. And if it is, we're going to specify the values M, P, and Q. And then we're going to list all the possible values of the random variable X. If it's not a binomial distribution, we're going to explain why. So in this example, it says a certain surgical procedure has an 85% chance of success. A doctor performs the procedure on 8 patients. The random variable represents the number of successful surgeries. So each surgery will be a trial, and there are going to be 8 trials. And each surgery is independent of the other. So what happens during one surgery will not have an effect on another surgery. There are only 2 possible outcomes. Either the surgery is successful or it's not. The probability of success is 0.85, and that's going to be for each trial because each trial is independent. And then the random variable X, it counts the number of successful surgeries. So in this case, the number of trials will be 8 because there are 8 surgeries. The probability of success is 0.85. The probability of failure will be 1 minus 0.85, which is 0.15. And these are the possible number of successful surgeries. You can have 0 surgeries that are successful, 1 surgery, 2 surgeries, 3, and so on, all the way up to 8. So all 8 can be successful. You might have 5 out of 8 that are successful, and so on. So that's how you determine your X. And this next one, it says a jar contains 5 red marbles, 9 red marbles, and 6 green marbles. And you randomly select 3 marbles from the jar without replacement. That's key, without replacement. The random variable represents the number of red marbles. So the probability that you get a red marble on the first trial will be 5 out of 20 because there's 20 marbles here and 5 are red. So you have a 5 out of 20 chance of getting a red marble. But once you put that red marble aside, you don't have the same number of marbles in the jar. Now you're down to 19. Okay, so the probability of getting a red one is no longer 5 out of 20 because you took a marble out. So the probability of success changes. Therefore, the trials are not independent because the trials are dependent on each other without replacement. Okay, so the trials are not independent and the probability of success is not the same for each trial. So now we're going to calculate probabilities for binomial distributions. And you can do this by hand, or you can use my Excel template, or you can use StatCrunch. So the probability of exactly X successes in N trials is this formula. Now, when I was in school, we had to do this by hand. Back in the Stone Ages when we didn't have technology like we do today. But the formula is, and you're going to look at this part here. Let me get my pen out. So this is the main formula that you look at, this here. N factorial over n minus x factorial times p raised to the x power times q raised to the n minus x power. Okay, and once again, I gave you the letters and what they represent. So let's go through an example. A rotary cuff surgery, rotator cuff surgery has 90% chance of success. The surgery is performed on 3 patients. Find the probability of the surgery being successful on exactly 2 patients. So let's write out the information. They gave us 3 surgeries. The probability of success is 90%. I'm just going to change this to 0.9 here. And the probability of failure is 0.10. And then we want to know the probability that you get exactly 2 surgeries, successful surgeries. So this is what you're going to calculate, the probability that x is equal to 2. So we got our information. We're going to plug it in. This is 3 factorial, 3 minus 2 factorial, 2 factorial, times 0.9 to the second power, and then 0.1 to the 3 minus 2 power, or just 1. Now, if you have a calculator that does factorials, you're good. You can actually do the factorials by hand because these numbers are small. And when you do this, you get an answer of 0.243. So the probability that you get exactly 2 successful surgeries will be 0.243. Now to do this in StatCrunch, you're going to go to Stat, Calculators, and it's going to be a binomial calculator. And all you have to do is put in the information. We know that there were 3 trials and the probability of success is 0.9. Here is where you change the inequality symbols or the equality symbols as well, because we do have an equal. So in this one we want exactly equal to, and then we're going to change this to 2. And when you hit compute, as you can see, we get our answer 0.243. I also have an Excel template that will do this for you. So in this one, the probability of success is 0.9. We have 3 trials and we want exactly 2. Now with my calculator, it's sort of set up like StatCrunch. I have the different outcomes here. You can have equal to, you can have less than or equal to, greater than or equal to. So in this one we're looking for exactly 2. So we want equal to. So that would be this here, 0.243. All right, let's look at another problem. A survey found that 17% of U.S. adults say that Google News is a major source of news for them. You randomly select 4 adults and ask them whether Google News is a major source of news for them. Find the probability that exactly 2 of them responded yes, or and the second one is at least 2 of them responded yes, and the last one is number 3, fewer than 2 of them responded yes. So we have 3 problems that we need to calculate. So we already know the information. They told us that they looked at they interviewed 4 adults and they asked them the question. P, the probability of success is 17% or 0.17. To find Q, you subtract 0.17 from 1, you get 0.83, and our first problem is asking us exactly 2. Okay, so we want to calculate the probability of exactly 2. P is 2. You may also see it written as this. That's the same thing. Okay, so let's go ahead and plug our information into StatCrunch. We have 4. Probability of success is 0.17 and we want exactly 2. And I get 0.119. 0.119. You can just put 0.12 if you want. The next question asks, if I go back, what's the probability that at least 2 of them responded yes? So at least 2. So this time we're dealing with an inequality, at least two. So we want two or more. So we want x is greater than or equal to 2. Now, if you do this by hand, you would have to calculate the probability of 2 plus the probability of 3 plus the probability of 4. That's if you do it by hand, but you don't have to do that when you do StatCrunch. What you can do is just change the inequality symbol. So if we go back to StatCrunch, this inequality symbol here where it says equal to, you have options. And you have to be careful with the wording because greater than or equal to and greater than are two different calculations. So in this case, we want greater than or equal to 2. And I get 0.1366. You can just round it to 0.37. Sorry, 0.137. Okay? But like I said, if you do it by hand, you're going to have to calculate each one of these and then add them all up. But doing it on the computer with the technology is easier. Now, if we go back to my Excel template, probability of success is 0.17. We have 4 trials, and we want more than 2. So in this one, like I said, I have all the probabilities calculated over here in the yellow. And we just have to pick the correct calculation. So we want greater than or equal to 2. So that would be this last one here, 0.1366 or 0.137. Okay, as you can see, we have greater than here and we have greater than or equal to here. So as you can see, it gives us different calculations. So you have to be careful with the inequality symbols. Okay, and the last one wanted us to calculate the probability that is fewer than 2. So in this case, it will be the probability that x is less than 2. It will not include 2. It said fewer than 2. Okay, so if you were to do this by hand, you would calculate the probability of 0 plus the probability of 1 plus the, oh, that's it. That's all you have to calculate because 2 is not included. All right, so in StatCrunch, all you have to do is just change the sign to less than. Do not put less than or equal to. You get 0.863. 0.863. Okay. If you go back to my Excel template, all the information is entered. We want less than, so we got this here, 0.8634. So it's the same thing. So once again, with my Excel template, you just put the numbers in the little pinkish columns, and then all the answers will populate over here to the right. So I gave you a little table that tells you what symbol to use based off the wording of the problem. So if you see something like fewer than, and that's what we just did, it was a less than symbol. More than is a greater than symbol, and so on. So you can look at the words and match it up to the wording in the problem. Alright, so now we're going to talk about how to calculate the mean, variance, and standard deviation. And this is something that you can basically do by hand. StatCrunch will not do it for you. My Excel template will. So to calculate the mean, you take the number of trials times the probability of success. To calculate the variance, you take n times p times q. And then to get the standard deviation, you just take the square root of the variance. So in this problem, it says in Pittsburgh, Pennsylvania, about 56% of the days in the year are cloudy. Find the mean, variance, and standard deviation for the number of cloudy days during the month of June. Interpret the results and determine any unusual values. So we're looking at the number of days in June. So n is 30, and each day is independent of each other. The probability that it's cloudy is 0.56, and then the probability that it's not cloudy is 0.44. So I've gone ahead and calculated the numbers for you. So the mean will be 30 times 0.56, you get 16.8. The variance is n times p times q, you get 7.4. And then you take the square root of 7.4 to give you 2.77. So like I said, StatCrunch will not do this for you, but if you go to my Excel template, it will. So you got 0.56 and it's 30. If you look, you don't even have to put in the number of successes because it's not asking you to calculate a probability. It's only looking for the mean variance and standard deviation. So you only need to put in information in the first two boxes. And if you look down here at the bottom right, you get 16.8, 7.392, and 2.71. And that's the same thing we got on our Excel file. Sorry, on my PowerPoint. All right. So let's interpret this. So on average, there are 16.8 cloudy days during the month of June. That's our mean, 16.8. The standard deviation is about 2.7 days. And then it says values that are more than 2 standard deviations from the mean are considered unusual. More than 2 standard deviations away. So if you take 2 and you multiply it by the standard deviation of 2.7, you can add and subtract it from the mean. So 11.4 will be below and 22.2 will be above. So a June with 11 cloudy days or less will be unusual. And a June with 23 cloudy days will also be unusual. Okay, that's the end of this lecture.